Okay, so here we have a smiley face. And let's start drawing the PSTN. And while I draw the PSTN, I'm going to also try to identify all the different key terms that we are talking about in this chapter. So let me know if there's something that I haven't mentioned, and I'll make sure I cover it. So inside of this public switch telephone network, we have different telephone companies. And I'm just going to draw circles. So these telephone companies are interconnected with each other. The connections between them are referred to as trunks. So a trunk is just essentially a wire that allows for a phone conversation to occur. Make sense? So there's different types of these telephone companies that exist. So, for example, this could be TDS, and then TDS has several different offices all over the United States, correct? Okay, this could be Mount Orab Telephone Company, and they have multiple connections. So they have a little network inside as well, and then they connect to other companies using some sort of trunk lines. And the trunk lines can consist of fiber, consist of copper. Rarely would it ever be wireless, but those are the type of trunk lines that you have. Okay? So the type of signaling that's used on these trunk lines is signaling 7, SS7. So SS7 is used between phone companies to route calls. It's kind of like their routing protocol. All right. Now, once you connect your house to a local telephone company, this connection right here to your home, and then here's your telephone. This connection is called the local loop. The connection that goes from the outside of your house to the telephone company is your local loop. Or it's also referred to as the last mile, albeit it can be longer than a mile long, but it's the last mile. So those connections usually come from the telephone company, the local telephone company, the local exchange carrier, we call that, via copper wires. They're starting to put in fiber, and they're calling this fiber to the curb, where it's fiber optic to the curb, and then from there, or for that neighborhood, it is then converted to copper as it goes underground or up to your house. That's a local loop. This connection right here at the house is called a point of presence, or the network interface device, NID. And I don't think that's a term on our sheet, but we can add that. Point of presence. This is where the responsibility of the telephone company is relinquished inside your house to the owner of the house. So this is your responsibility inside the home, everything from the point of where they attach to your house and underground or on the telephone pole back to the telephone company. That's their responsibility. So that's why they call it the point of presence. They're calling it a network interface device now. They started doing that about 10 years ago or so, because this is also the point at which they might convert from fiber to copper, or to some sort of device that might be even mounted inside of your home that's still owned by the telephone company, but that would convert it from a Ethernet signal to an analog signal, or from some type of signal to another type of signal, depending on what services you're getting from the telephone company. And or now you can get services from the cable TV company. They're providing services through their connections. So even a cable TV company like Charter can provide voice services. So their NID, or point of presence, is that device, that box, that is converting the signal from whatever they have out here into a signal that's going to work inside your house for getting phone service and internet service and TV service or video service. So that's where the NID has come into place. All right, let's take a look at how this connection now applies to a business. So an older business would purchase a trunk line on this last mile. And I'm going to draw my big building here, not too big. So this would essentially still be called the local loop. But the moment it comes in, what is this point called? Do you remember? Point of presence. Yep. So this point of presence then comes in, and then the connection is made to a key system. A key system is an older telephone switch that is used within a private organization. The goal here is that when you connect telephones, each telephone has an extension. Now, this connection here is also referred to as a trunk. That trunk line can come in many different forms into this key system. It can come in as a POTS line. POTS stands for plain old telephone system. That's what this is. In your house, you run a POTS. That's what your phone is in your house when you have an analog phone in your house. It is a POTS, plain old telephone. So if it were a POTS line for this key system, depending on how many customers we expect to be calling us at the exact same time, determines how many POTS lines we need. So if we can expect up to 3 customers calling us at any given time, and we will be also making 1 or 2 outbound calls at the exact same time. We have 3 customers calling in. 3 customers plus 2 outbound calls from one of these employees. How many POTS lines are we going to need? 5. Because if we only have 4, we have 3 customers calling in, and then one of our employees is calling out for support. Then the 5th one who tries to call out, what's going to happen? They're essentially going to get a busy signal. They won't be able to seize a line. They won't be able to seize an available line. So with this key system, we have lines 1 through 5 on each phone. So you can see on these phones, in the past, you could actually see which lines were in use. They would light up. So if you go to pick up the phone, you want to make a phone call to your house, you would have to pick line 1 through 5, and what would happen then is you would use the POTS lines 1 through 5, or how many lines we had, you would use one of those lines. So if you chose line 3, then line 3 would light up on each one of these other phones in the business, and they would see that line 3 is in use right now. And then when someone would call in, line 5 would be picked. And so line 3 and 5 would be lit up. Does that make sense? That's a key system. Each line is showing up in each extension. So this is a small business. So the POTS line, another solution that's kind of going by the wayside is the use of ISDN. ISDN uses 3 channels. Two of them are at 64 kilobits per second, and one of them is at 16 kilobits per second. This one channel at 16 kilobits per second is where the CS or the CCS is used. And on our little list here, CCS is signaling that uses a separate dedicated channel for all signals. CCS. So if one channel or ISDN line is being used for signaling, like keeping track of what lines are in use and what are not, then I can have up to 2 voice conversations going on at any given time using ISDN. So ISDN still comes in on 2 wires, but it's split up into 3 channels. Does that make sense? So it's still broadband communication, channelizing the signal that's coming in, and it's digital. It's a digital signal where POTS line is analog. And the communications from my key system to the local exchange carrier is still using signaling 7 when it's using a POTS. When we're using ISDN, what signaling is it using? Starts with the letter Q. Yep. Yep. Q 931 signaling is used with ISDN. Where here, the signaling that's being used is SS7. For POTS lines. Okay, so now we go to a larger business. We'll make a larger building for larger business. Again, this is a trunk line. So the trunk line still is called the loopback, the local loop. Still a POP, point of presence. This local exchange character is also referred to as the CO, the central office. It's another term for the local exchange carrier. Local exchange carrier. So at a larger company, they're going to connect this trunk line, whatever we decide to use, and we're going to talk about a few others here. They're going to connect it to a device called a PBX. The whole purpose of having a key system or some sort of switching device inside of your company is that the majority of your phone calls are going to be made between your employees as you're communicating and conducting business. And then the other percentage of calls are going to be going out to the central office or out to the PSTN. So in a larger business, you're going to use something called a PBX, a private branch exchange. meaning it's going to function similarly to the local branch exchange, but it's your own private branch exchange. And the type of trunk line you're going to get is going to have to be a trunk line that is going to be able to support larger call volume. The larger call volume can come in on a trunk line on a DS0 or DS1, which is also referred to as a T1. And a T1 is similar to ISDN. The DS is digital signaling, so it uses digital communications, and we have 24 channels at 64 kilobits per second. So that means we have 24 phone conversations. Oh, but wait, we have the CCS. So that means we have 23 because we have the one channel dedicated for the CSS, for the signaling. No, I'm being dyslexic here. It's not CSS, it's CCS. Common carrier signaling. So we can, with the T1, we can have 23 voice channels. So in my PBX, I have my extensions. I'll make a better phone symbol. And each phone has its own extension. And when they want to dial out or use the outside line to connect to the public telephone network, they usually will dial an access number, like 9. So by dialing 9, what happens is, inside the PBX, it's doing something called TDM. Time division multiplexing. So TDM kind of works, this is like the symbol for a multiplexer. It's allowing all of these connections, and it's using time division multiplexing to allow a connection to be made when this phone call wants to be made. When this phone seizes a line, dials 9, it's going to grab one of these 23 channels to communicate out to the internet. So time division multiplying allow one communications to many or many to one communications. Okay. So now that we have kind of the basic layout of these different companies, let's throw in there one last large company that's going to use voice over IP. So the voice over IP in this company in this large business is going to have a data network set up, and they're going to use that data network. It's going to be essentially what we call a converged network. It's going to use the same switching infrastructure that the PCs use. They're also going to have their IP phones connected to it. We can also have our IP phones as little mini switches. So our PCs connect to the switch directly, or they can go through the phone and connect to the network. what happens is, in this type of scenario, is that the phones are put on their own VLAN or their own network, and the PCs are put on their own network. So VLAN 10 for the PCs and VLAN 20 for voice. So the communications are separated, and a higher quality of service, or QoS, is applied to the voice VLAN, meaning the switch will then make a decision to forward the frame coming from the phone first before it does for the VLAN 10 for the PC. So that provides a higher quality of service to the voice conversation than just normal data communications. Because that website can wait a few milliseconds to load. Where that voice call, if it waits, you're going to get choppy communications, and it's going to be hard to understand what the person is saying. So this switched network then is going to connect to some sort of router, just like we're used to. And this company then is going to have its calls managed by some sort of device. So if we look up here, the small business used a key system, this physical device that hangs on the wall that monitors and allows voice conversations to occur between each other and then outbound to the public switch telephone network. Well, over here, we use this device, the PBX, the private branch exchange, which allowed us, using TDM, allowed us to actually seize a line and communicate out. So we need some sort of device here in this large business using voice over IP to do the same thing. So off of this network, we put some sort of call manager server. This call manager server essentially is going to run an application /service to allow these phones to have extensions and to dial each other. So what they do is they essentially log in to the server by saying, hey, I'm this device and I want to talk to you. I want to be part of your telephone network. And this phone does the same thing. Then what happens is the call manager assigns an extension. So you're going to have extension 2101 and you're going to have extension 2102. So the call manager assigns extensions. So when I'm here on this phone and I dial 2101, the call manager rings this phone or makes it create a noise. It's not the same as ringing a bell up here by increasing voltage. It's now a data signal saying, hey phone, make a noise. So the phone makes a noise, and once this person picks up this phone by taking it off hook. So when I have a phone, this is on hook, this is off hook. Another term that you need to be familiar with. On hook, off hook, because this is the hook. You're going to hang the device up on the hook. You've seen the old television shows or movies where they have the little handset. They pull it out, put it to their ear. On the hook was on the side of the telephone. So on hook, off hook. On hook, off hook. That's all that's doing. Okay? So when they take it off hook, what happens is the call manager tells this phone, you need to establish a stream of data to this IP address. So now they use IP addresses and the phones now communicate to each other. Call manager's out of the picture. The voice conversation, the stream of data goes like this. They only use the call manager to find the extension of the device they wanted to talk to. Once it's done, the data flows from device to device. Call manager's out of the picture. So this call manager could get unplugged or turned off, and this voice conversation will still keep going. Until, of course, they hang up, and now when somebody tries to call them, they're not going to be able to identify it because the call manager won't be there to identify where that phone is. So the call manager is kind of acting like a router. It's routing phone calls, right? We can also turn the router into a call manager, into some sort of device that is going to allow phones to register with it and to identify an extension that they can have. So let's put that scenario into play with another remote office. So if I have a remote office, I'm going to have a router, and I'm going to have phones and computers hooked up to a switch. That switch is going to have a connection to that router. Right? We'll call this the remote office. So this remote office is going to have some sort of connection from their router to this router. Because what's the purpose of having a remote office? The remote office can't access any of the files and into the servers at the main office to get customer information or whatever they want to see for their data. So we have some sort of connection between the two. And this is sometimes a T1, sometimes a T3, or this could be a wireless bridge. If it's just here and 3 miles away, I could set up a little wireless bridge. Some sort of connection. This could even be a VPN, a virtual private network. All we need, though, all we're sending back and forth here is data. This T1 connection, right? We're paying for this, however we're paying for it, to make the connection from this network over to this network. So now I have this phone. This phone needs to register. We could, it's not best practice, we could just tell this phone, register with this call manager over here. But now what happens when this connection is down? Then these guys over here will not be able to make phone calls to each other. But let's assume that there is another phone over here. So these guys won't be able to make phone calls. So what do? We put a small version of this call manager inside of the router. And Cisco actually calls this a Call Manager Express. It's a small little version of the voice call managing service that's running in the router iOS. Okay, so far in this voice over IP system, we can now make calls. So if this Call Manager Express says you're going to be extension 3101 and you're going to be extension 3102. This call manager, this router, is registered with this call manager. So this call manager and this call manager know that each other exists. And just like routing protocols, they identify, I have extensions that start with 3. So they go, I have a bunch of phones over here with extension 3. 3101, 3102, and so forth. This call manager goes, oh, great, I'll create a route so I know to send all of the voice calls to you if someone dials 3101 or 3102. And then this call manager says, FYI, I have all of the 2 extensions, 2101, 2102, and so forth. So this call manager has a route in it that says, send all the calls to this call manager if I'm dialing a 2 from here. So I dial 2 and then 101, it knows to route that to this call manager, and this call manager will then send it to the phone it needs to go to. And then, just like before, the communication flows only from device to device. the call managers are not in play. The moment that voice, the connection is made between the two, creating a little session. So now we need to go, okay, we can call each other inside the business. What about making a call out to customers, or allowing customers to call in, or calling other businesses? And that's where we need to somehow establish a trunk line. So we can establish another trunk line to the central office. And that trunk line, just like with the PBX, can be a digital signaling 0, which could be a T1 with 23 channels, or 24 channels with 23 voice channels. Or it could be a T3 with, I'm guessing here, 64 channels possibly. So I might be wrong on the number. So I can create a connection here. I can even use what's called a channelized T1, or a partial T1, where I can have this T1, I can have only, let's say, 16 channels. So I can get just part of a T1. Depends on how much I want to pay. I don't need all 23 or 24 channels. So how does this work? We need some sort of module to be put into this router to act as a gateway. A gateway between the analog world, or the PSTN world, and our IP world. Because here we still use SS7 signaling. We still use the signaling that the telephone companies, the central offices, the local exchange carriers are going to expect. So we need to somehow convert our voice calls that are IP based and packets into a digital signal over a T1 channel that's going to be recognized by the telephone company. So how do we do that? We need some sort of module there. That module is called a DSP. Better marker here. That DSP, that's going to allow the conversion between analog and digital, or digital to digital, some sort of carrier that's going to allow for that signaling to take place. Now, for safety purposes, we should probably also put some sort of module in here at the local office. Because in case this connection goes down between the two sites, we still want these guys to be able to call 911. Very important. So this could be as simple as a POTS line. Because all we need is that one line. So all the phone calls, by default, when this phone makes a call home from this business remote office, it gets routed to the main office, to the main router, using one of the trunk lines here. This is a cheaper call. But if by chance this person needs to dial 911 because someone's having a heart attack, it will then seize this line. It has a route pattern in here that says we need to use the local connection because this 911 call is going to have the local address assigned to it. Where if the 911 call went out this way, the ambulance would show up to the main office, not this other remote office location. So that's why this is important for E911 services. All right, so who's been going through the list of vocabulary and which ones have I missed that we need to identify? Where on here are they taking place? So going through the list, start at the top. TDM, time division multiplexing. We've placed that one. Local loop. We've placed that one. A key system. We've placed that one. Glare phones. Or glare, not phones, glare. When outgoing and incoming calls collide on the same phone line. So on one of these channels, we can have glare. Collision, where we have a call coming in and a call at the same time being seized to go out. This is called glare. It happens at the exact same time, a collision. PVDM, hardware modules added to routers to provide resources for analog voice. So analog, POTS line is an analog voice. So here, this DSP, we call a PVDM. PVDM. G711. G711 is a medium complex audio codec with bandwidth of 64 kilobits used in Cisco IP phones. So over here, these phones, this phone conversation, I'm going to write it in yellow, G711. It is a codec. You guys see that okay? G711. It's a type of codec. So G77 communicates at 64 kilobits per second. Okay, well, the 64 kilobits per second would work great for this conversation. But would it work for a 128 kilobit VPN connection? No. It would use up way too much bandwidth. So we go with a smaller codec. What's another smaller codec in this list? G729 is another codec. And this uses 8 or 16? 8 kilobits per second. So that one might be more appropriate for a call going through a VPN connection or a WAN connection with limited bandwidth. Let's see if we have any other. There should be a medium one as well. That's what the G7 was. Medium. Where's the high one? G7 is medium complexity.
High complexity is the G7.
Which one? What do you have?
G729 was the high complexity audio codec.
Oh, it's highly complex, meaning trying to compress it as much as possible, using 8 kilobits per second as opposed to 64 kilobits per second. So the lower the complexity, the more bandwidth is needed to turn the sound, the analog voice, into a data packet. That's called a codec, changing it from one medium to another. Where are we at here? So G71, central office, identified. CAS. A CAS, signaling in which signals are sent in the same channel as the voice traffic. That's where we'll place this. The signaling in a local loop, a POTS line, local loop connection, is where the signaling information is sent right alongside the voice traffic. RTP, Transport Protocol for IP-based digital voice. The communications that's going back and forth between the call managers and the phones, phone-to-phone conversation, is RTP. It's Transport Protocol. Okay, so this one, loop start and ground start. Loop start is the common signaling for home phones in which the circuit to the phone company is open or closed. So this type of a call is loop start. When I use a key system and I use POTS lines on this key system, I want to use ground start. Ground start allows me to avoid glare, avoid this possibility from happening. So what happens, if you ever had this happen to you, where you pick up your older analog phone in your house, and you are talking to someone, and then you hang up, and immediately want to call somebody else. You put it on hook, then take it off hook. And guess what? The other party you were just talking to is still there, because they haven't hung up yet. Has it ever happened to you? Okay, that is loop start. So you have to push and hold and wait. You essentially have to time out the circuit that was created on this loop start connection. Where with ground start, the key system or PVDM or DSP device is going to send an actual signal and ground the circuit. What happens when you ground a circuit? It goes away. There's no more circuit, right? So it's going to ground that circuit so it will disconnect. Wouldn't it be strange if you're in this business and we're talking to Sally on this phone as a customer, Sally, and then I go to hang up with Sally, I go, okay, thank you very much, and I hang up, and this person goes and seizes that line that Sally was on, and then starts dialing, and Sally hears a bunch of beeping and goes, hello? Oh, hi, I was trying to make an outbound call. Who's this? It'd be kind of weird and awkward. So we try to use ground start. And that's all taken care of by the central office or the local exchange office. They identify what type of POTS line this is going to be. Is it a ground start or loop start POTS line? To homes, it's loop start. The small businesses or businesses that get a POTS line, they're going to use ground start. PSTN, we covered that one. G729, that's 8 kilobit codec. DSP, right? The device that is going to, the chip that is going to convert the digital. Okay, the DSP is actually inside of the PVDM. It's a chip on that device. So it'd kind of be, I don't have that. There would be like a chip on a card like this. So this is the PVDM, and the chip on here is called the DSP, the digital processor. Moving on, trunk line. Talked about that one. The central office switch. E164. E164 is the International Numbering Plan. Okay, so when this PSTN, when we have connections from within the United States out internationally, let's say to Italy, we have to use a numbering plan that's going to route, because internal we just dial 1 and then the number, right? 1-608-822-3262, and that will dial a local phone number within the United States. If we want to dial out, we have to dial 011 and then the country code, and that tells your local exchange carrier we need to seize a trunk line out to some international switch. So we know we're making a call to some foreign exchange. And that is the E164. SS7, signaling 7 is used between phone companies to route calls and information about the call, like caller ID. And then we go to ground start. We've talked about that one. RTCP, protocol to provide statistical and control information for voice calls. RTCP, more information that's getting passed back and forth between these. RSTP. Or RTCP. Again, dyslexia. RTCP. Thank you. RTCP. MOS, M-O-S, is measurement to compare codecs. So let's throw that with these codecs signaling here. Compare the difference between the codecs and the quality of the call. Q931 is ISDN. Talked about that one, ISDN circuits. Use the Q931 protocol. PBX, private branch exchange in a local company. Quantisation. One of the steps in the process of converting an analog signal to a digital signal. So, especially when we're dealing with voice over IP, there's a lot of that happening. Essentially, it's trying to quantify an analog voice conversation into digital signals, ones and zeros. So that's called quantization. And then these devices, like the DSP, that's their job, is to quantize that signal they're receiving and convert it back. And then CCS, signaling that uses a separate dedicated channel for all signals. That's where we dedicate one channel out of these 24 for signaling. The same thing happens with ISDN. So the signaling is we're establishing a session on this channel, good. Now we're terminating it, good. Or we need to maintain it, keep it up, keep alive. So that's the signaling that gets sent back and forth between devices. That CCS for those channels. Any questions on any of those? A lot of information.